Alright, ladies and gentlemen, this is going to be the next video on water and polarity. What we're specifically looking at now is water and hydrogen bonds. Let's go through and get started on this next video. So let's go through and think about the significance of water. 71% of the earth is water, and your body is anywhere between 60 to 70% water. Now, water, like carbon, has a special role in living things. It's needed by all known forms of life. It's a simple molecule just containing 3 atoms. 75% of the surface of the earth is covered by water, and we can see that water generally refers to its liquid state. We normally think of that liquid water, but it's again important for us to remember that water can exist as solid ice or as a gas. Now, the game plan for this video is we need to understand what a molecule is and make sure we have a clear understanding of what that is before we delve into water. Then we are going to go through and understand how water's relationship with electrons is going to affect its polarity, because polarity and hydrogen bonds are key for understanding the properties of water and its relationship with life. So let's go through and look at these two things and make sure we understand and think about how we're breaking the video down in order to better understand the content. So when we think about a molecule is simply a group of atoms bonded together. They are going to represent the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. Now, water is going to consist of 1 oxygen, represented by the blue circle here, and we can see it's going to have 2 hydrogens at the bottom. That is going to be representative of those 2 hydrogens that are covalently bonded to the oxygen. Now that we understand what a molecule is and we understand the components of water, we need to understand what a polar molecule is. Let's go through and read this definition carefully. A polar molecule is a molecule that has a slightly positive and slightly negative end. Now, if we look at this water molecule here, we can see that the oxygen is going to have an overall negative charge, whereas the hydrogens are going to have an overall positive charge. Question is why is that? Why do we see this overall charge and this difference in positivity and negativity amongst the molecule? Well, the reason this occurs is it has to do with how the electrons are shared. So the oxygen here, hydrogens are in the red, 1 oxygen and 2 hydrogens. In the first shell, if you remember back from chemistry, we have 2 electrons, and this is a covalent bond. So we're sharing these electrons. So because of that, what we can see is in that outer shell, which is going to hold those 8 electrons, we're seeing that a set where 2 pairs of them are being shared. Now, when they are shared in that outer shell, it's going to potentially cause a change in the polarity based on the size of the individual atoms and how the electrons are shared. Now, the way that I like to go through and think about this is because there are more negative things around that oxygen, we're going to see an overall negative charge. If you have lots of negative things going on, maybe in your life, you're going to be an overall negative person. However, what we see is those hydrogens have less of these negative electrons floating around them. So because of that, the hydrogens have less negative particles. So what we can see is they have an overall positive charge. Now, there's another way that we can go through and think about why the oxygen is more negative and why the hydrogens are more positive. This is an incorrect explanation, but it's an interesting way to think about it. As the electron is going through and floating around the actual molecule, it's spending significantly less time around the hydrogens and spending more time because the oxygen is significantly larger. Because the oxygen is larger, it's going to pull and attract those electrons more, causing an overall negative charge. So because of this, what we see is this resultant uneven sharing of electrons creates these partial charges where the oxygen is negative and the hydrogens are positive. Now, it's important for us to understand that this covalent bond, this sharing of electron sets, is what's going to give the negative charge to that oxygen and the positive charge to that hydrogen. That's the covalent bond, and that's the bond or the sharing of these negatively charged electrons between the individual atoms. Now, what we can see is because of these arrangement and charges, we're going to see that these positive ends, because of the uneven sharing of electrons, are going to attract larger water molecules towards each other, and there's going to be an interaction amongst those molecules. Now, what we can see here is the interaction between the actual molecules. Again, we're not talking about atoms. Atoms is the covalent bonds. Hydrogen bonds is the interaction between each water molecule, the positive and negative ends. So a hydrogen bond is the attraction between a hydrogen atom on one water molecule and the oxygen atom. You can see as this interaction is what's going to cause different things to occur with water molecules. Now, based on what I just discussed, it's important that I make sure that we're clear and understanding this. Covalent bonds, that is the individual sharing electrons between the atoms. We consider this an intermolecular force because it's between the atoms. The covalent bonds are forming in the water molecule between the atoms. What we can see here is the hydrogen bond is between the water molecules. This is an intramolecular force. Inter is between atoms. Intramolecular force is between molecules. Now, an intermolecular force is going to go through and again form between the atoms. And what we can see here is the covalent bond is what's causing the uneven charges, but again, it's because of the sharing of electrons. It's crucial that we understand this. Intramolecular forces are between the water molecules. When I say intramolecular force, we're going to see these polar molecules, and the polar charges of those molecules is going to form hydrogen bonds between the water molecules. And I am emphasizing molecules because in intramolecular force, hydrogen bonds are between water molecules. These hydrogen bonds are between water molecules. Now, the arrangement of these water molecules, and because of the polar charges, we're going to see different interactions of water depending upon if it's a solid, a liquid, or a gas. We're going to see all these things that occur, and how organisms maintain homeostasis is because of these hydrogen bonds. But remember, this is a bond between charges, not the sharing of electrons. Hydrogen bonds are between the molecules, the positive hydrogen and the negative oxygen, but the overall molecule is going through and causing the charges to occur. All right, so did you learn? Well, did you learn a couple of things here? Did you learn what polarity is? Did you learn why water is polar and its relationship with these negatively charged electrons? And did you learn what a hydrogen bond is? All three of these things are important in order to understand the rest of the unit. This is going to be the end of the video. We'll see you all in class tomorrow.